As far as the characteristics of sound are concerned, we have three main characteristics for sound. Sound that we come across, that we hear, it has basically three characteristics. One is pitch, the other is loudness, and finally you could say the quality of sound, or it's also pronounced as timbre. First of all, we are going to focus on pitch. Pitch is mostly confused with frequency, but I am sorry, it's not frequency. It's quite different from frequency. Although we could say that higher the frequency, higher is the pitch. That means with the increase in frequency, the pitch is going to increase. When you say it is a sound of high pitch, it simply refers to sound of high frequency, no doubt, but you can't replace frequency by pitch or vice versa. If the frequency is high or the pitch is high, sound is normally said to be shrill or sharp, like buzzing of bee, that is a sharp sound. Or other examples are also there. You see, whenever in simple way, you see, if the vibrating object is very small, the frequency produced will be higher and the pitch will be higher. If the object oscillating is of bigger size, that is bulky in nature, means like rock and mountains, if they are in vibration, obviously the frequency produced is going to be low. The frequency that we could hear is always between 20 and 20,000, that is known as audible frequency or audible range of frequency from 20 to 20,000. But you see, our human ears have their own design in such a manner that they have a very good response for the frequency ranging from 2000 to 5000 hertz. The human ear's response is quite high in this range. When the frequency is less than 20, then this is called infrasound, and as I told you, this is possible by the vibration of bigger objects, voluminous objects, the objects which are bigger in size. And when the frequency is higher than 20,000, sound is referred to ultrasound. Ultrasound has got so many applications in medical field. When you see, ultrasound has replaced X-ray simply because X-ray is electromagnetic radiation that could damage the cells, live tissues. But ultrasound being mechanical wave, it doesn't harm. That's why it's preferred for infants and small babies, newborn babies. Ultrasound has so many other applications also, like sonar. Sonar, that is sound navigation and ranging. With the help of sonar system, we could detect any object immersed inside the sea. Sonar has also got many wider application. You see, if sound is short tempered, or you could say of short duration, it's not so, you see, useful. If sound is having the tendency of longer sustainability, then it allows us to determine the pitch and all other essential characteristics of sound in detail. So, we always prefer the sound which has the sustainability comparatively higher. Then Western music, you see, and classical music, how you differentiate between the two. In classical music, we have 7 intervals and 8 notes. Sa, re, ga, ma, pa, dha, ni, sa, that is normally told as. And in Western music, we have there 12 notes and 11 intervals, that is do, re, mi, fa, sol, la, si, do. There are 2 scales. One is known as diatonic scale, that is this, and the other is equally tempered scale. Equally tempered is Western music. Western music is entirely based on equally tempered, that has common ratio throughout from first to last octave. You see the whole set, that is in Hindi it is also called Saptam Swar, that is 7 intervals and 8 notes. The first and the last, they have the ratio 1:2. So, 1 octave refers always to the ratio 1:2. But you have to remember, you must remember that in diatonic scale or in classical scale, the ratios of sound that have been taken, ratios of frequencies, they are a bit typically different and a bit complicated also. Whereas in equally tempered, you always find the same geometric ratio 1.00, that is common to all. Then In musical instrument, pitch has very wide application. By knowing the pitch, we could control the quality, the pleasant behavior of the sound that could also be controlled by controlling the pitch.